inevitability, the grim fatalism of this current model. So this model would not be, if we compared this model against any empirical data, even rough qualitative data about weight change in the world, it would quickly prove its limitations. Although there's really powerful feedbacks. I mean, it's actually distressingly powerful that mean that once you've gained weight, it's easier to regain it after losing weight again. There's some issues having adipose cells in the body. Once you've built up a certain number, they can shrink, but basically the number is conserved, so they can grow back to their original size much more easily than de novo lipogenesis, the creation of them from the get-go. And there are some issues that make it not quite lock-in effects, but something close to that, where it's hard to get out of that state. Your body again slows down its basal metabolism as you're losing weight because it thinks it's starving. So we could add a reverse link. Should we do that? Let's do that. And just in the interest of time, because we have miles to walk and twilight will be coming on. We'll make these very simple transitions. And so I'm going to have losing overweight, right? This would be a weight transition. Excuse me, a rate transition. Excuse me. With a rate of say 1.0. Okay. And then I'm going to have a simple transition, which is going to be from overweight. Let's try this again. From overweight to obese. Excuse me, from obese to overweight, which will be losing obesity, and I'll make that a rate transition of 0.25. Okay. So now we have some possibility when we become overweight of become obese of becoming overweight instead, and similarly going on from overweight to normal and underweight. And I put them in with rates that are rough and ready. I just said 0.25 for this one, and a rate of 1.0. You'll notice you'll need to make these rates, folks, not timeouts. We'll show some of the dynamics for timeouts in a bit, but let's leave them as rates for now. So this is a rate of 1, and this is your rate of 0.25. Okay? Is that okay? How long in average would someone be in the obese state on a yearly basis? How long would they remain there before they left? If the rate is 0.25 per year, how long would they be there on average? 4 years. Gosh, your students are great. Terrific. Excellent. So, ladies and gentlemen, can we try running this model? Run early, run often, try to observe the results of your changes, even though you may not yet be in a may not have achieved logical closure completely. Often it behooves you to run it and just make sure you haven't done something silly. So what should we see now that's different from before? What should we see now? Yeah, exactly. Okay, so now we see something very different than what we saw earlier. We don't have this grim inevitability. Obesity doesn't lie before us as a necessary endpoint. Instead, we see people gaining weight and losing weight. Do we not? See. Yeah. Okay, good. So ladies and gentlemen, we've got a good start, but we still haven't done one key thing here that I think there's an interest in putting into place. Okay, ladies and gentlemen, we still have this transition not depending on age, right? If we go look at this, what we'll see this transition is just a fixed rate. How do we make it depend on age? Well, we already put in place the basic mechanism, so I'll tell you what you'll do, okay? What you'll put here for the rate is this. This is what's called a lookup function. Do you remember this? We put this in place before lunch, and your memory of things before lunch may be limited. So just to remind, we had for a given weight, a certain transition probability. Okay? Sorry, given age, a certain transition probability. Given age, certain transition probability. Is that okay? Okay? So let's put this into place, and then I'll show you a gotcha. Okay? Watch this. So let's put that in place. Let's put in place this gaining overweight hazard by age. Okay? Gaining overweight hazard by age. You'll notice if I do this control space, it will actually propose it. And you'll notice that it takes something here. What do you think this thing is? It says double X. What do you think that is? Yeah, age, exactly. Because we know that because it's got a nice name, by age. So maybe you could say for age. So we have to give it an age for it to do its job. So how are we going to determine a person's age? Riddle me that. Current age. Man, you folks are good. That's just great. You've got me all enthusiastic about the prospects. Okay, great. Okay, so we say gaining overweight hazard by age for the current age. Okay? Now, should we run this thing? Should we run it? Okay. Watch this. Let's go run it. And by appearances, you would think it should work, but what's going on? What's happening? Look at that. Look at that. I'm running this thing. Where's all the action? Remember we had people gaining weight, losing weight, all that sort of stuff. What's going on? Okay. So that's a clever thought, and it actually does have to do with that gap. Remember what it was? What was the hazard for zero age? Zero. So it actually will have to do with this, but there's actually a confluence of two issues, and I'm teasing you a little bit, okay? There's actually a confluence of two issues here that we're going to tease out. Okay, so the first thing is that if you go and you look at everyone's age, go down and take a look. What's this person's age? Just remember, how do I go down and look at people in the population? Tell me where to go. Where should my mouse go? Left, right, up, down? Okay, this is exactly it. Go down. Okay, so what's this person's age? What's their birth time? 0. Okay. At the initial time, they were how old? The model starts at time 0. So how old were they when the model started? 0. How old was this person? 0, 0, 0, 0. They're all. It all said birth time 0. We didn't actually bother putting in that, and that's one problem. Everyone was starting at age 0. Everyone is starting at age 0, and therefore their rate was what? And therefore they never gained weight. So it wasn't tracking their weight. So, ladies and gentlemen, this is a sort of problem. Do you remember before where it gave us that problems window and we had to go track down? There are certain types of problems any logic will spot for you. It'll say, I don't know what's going on here. This is a more subtle problem. This problem is one that it won't tell us what the answer is. It says, hey, you want me to do this? I'll do it. It does exactly what we've told it to do. But what we've told it to do isn't what we thought we told it to do. So we have to fix two things here. The first thing we have to fix is it's not tracking people's age. And there's a reason for that. It turns out, ladies and gentlemen, that in order for it to take into account someone's gained age, we have to tell it, hey, re-examine their age. And there's a way we do this in any logic. I feel bad telling you this, but hey, you got to work. You got to drive the conditions. You got to work with the state of the software. And it's not that painful, but it's a little bit unpleasant. And to be honest, it gives me a little bit of the willies, if not the heebie-jeebies. So what I'd like to do is this. Watch this. For this state, we're going to need to tell it to re-examine this rate of outflow periodically. And I'm going to tell it to re-examine it every year. Okay? Every year, re-examine what the rate should be. So this is how I'm going to do it. I'm going to drag a transition out of this stock, and watch this. I'm going to take this, I'm going to double click here in the middle of it to give it another so-called handle, and I'm going to drag it. Oh, come on, don't give me that. Okay, there we go. Well, that looks most aesthetically displeasurable. Okay, there we go. Okay, that's not so bad. Basically, you're coming out of this state and you're re-entering it. Okay, that's a little bit better, isn't it? Aesthetics differ on these things, but even my engineer's aesthetics is distressed. Okay, so here we're going to tell it basically to re-examine this outgoing transition, recalculate it every year. So this is going to be a timeout of every 1 year. Okay? It's going to basically come out of here and go back in, and that's going to cause it to reevaluate this transition. Leaving a state and coming back into it is when it sort of recalculates the transition. So I'm sorry to say that with continuous aging, there's no magical way it's going to know to recalculate this. So we have to actually tell it recalculate. Okay? Are people okay with that? It's most displeasurable, but it's not that bad. Aesthetically, it's a bigger affront than it is in terms of practicality. How did I bend it? I bent it like Beckham. So actually, what I did here to bend it, I actually double clicked it in its middle, in its midriffs. I double clicked it, and that allowed me to drag it. So let me illustrate for you my technique. So I drag this in, and then I double clicked on it, and that created a little handle that allows me to drag it around. Is that okay? Oh, that'll be good. So we could say re-examine age-specific rate for becoming overweight. Okay, a bit too long for my taste, but it could be worse. So I just named it, and then I could show the name here if I want to, which might be something you want to do. Okay. For 1 year, yeah. I made it timeout of 1 year. That means every year on the year, it will go re-examine this rate and recalculate it. It actually was by default on years, because when I dragged it in, the model's time units, it's possible you missed this, but the model's time units are now years. And what that means is by default, the units are years. But you can always specify years here by choosing it. Yeah, no. Okay? Who needs Nolian help? Okay? Where do you actually put in 1 year? Or is it assuming it's only 1 year? Okay. Yeah, 1 is the default value there. Yeah. Okay, ladies and gentlemen, can we run this? What do you see when you run this now? Okay, oh, look at that. Okay, now we've got a different type of issue. And I wish I could honestly tell you that I'd planned this all out to sort of show you different classes of errors, some that are silent but deadly, like where it's just not working, some where it actually shows you a message while you're running the model versus some that it shows you problems windows. Those are 3 different classes of errors. And this could be a nice nugget. The 3 classes of errors. It's kind of like the 4 horsemen of the apocalypse or something. These are 4 different types of issues that come up in running these models. One is it's obviously not working, but there's no obvious indication why. One where it throws this message while you're running it saying it's unhappy. Another where it spots it before you can run it, and it gives you a problems window. Those are the 3 broad classes. So this is the type of issue you might encounter. Let's try to work this one through. I didn't encounter this. This is an emergent feature of my situation, although it's not one that I was seeking. So what do you think this means? That's right. Exactly. So what can you do for that? These are the real-world challenges that you might encounter grappling with any logic. So let's go. Let's go to the table function. And what you'll find here is that in the table function, there's actually this choice. It says out of range error, and that's why it's throwing that. If we're giving it a range that's outside of its range, if it's beyond 90, it'll throw an error. We can instead, for example, for out of range, say use the nearest value. And now, what do you think will happen as we run this? What do you think will happen? Think we'll see that error message? No, most emphatically not. Okay, so that's a start. Now we have people aging. Now evidently their rate of developing overweight depends on their age. That's encouraging. But there's still one piece that we still have to fix. And what is that? We saw it just a few minutes ago. Everyone's birth time, everyone's birth date, as it were, is what? 0. So we need to change that. So riddle me this, building on your strengths from this morning, building on your emerging understanding, where would we go to specify the characteristics of the population in terms of the distribution of something like income or sex or indeed birth time? Where would that be specified? Where in the model would that be specified? In Maine. In what thing in Maine? In the person lives in they're embedded in a yeah, okay. Good. Yes, in a population. So, where would we go look? Well, you could see there's a thing that says birth time here. We didn't fill a value in, so it filled that in essentially for us, 0. So we're going to draw the initial population from being from some distribution, and we can put in place. Oh, let's do this. Oh man, this is such a nice. This is just setting it up. Let's do it. Okay. So, ladies and gentlemen, let's go to Maine. We're going to put in place a custom distribution that's going to capture your distribution according to your characteristic, and we can draw people from that distribution. So let's go to Maine, double click on Maine, and let's put in place a custom distribution here. So in the palette, in the agent part of the palette, there's a custom distribution. And I'm going to drag that in, and I'm going to say initial age distribution. Okay? This is something we also, I don't think, did this too much in Adelaide. Are people comfortable with that? Okay? And you'll notice that this is an extremely useful thing. This is what I was referring to earlier when I talked about a custom distribution, say, for sexes. What fraction of the population is one sex or another? For that one, you would have chosen type options, and you would specify, I'm not going to do it, but you would specify, for example, the distribution by sex here. Okay, I'm surprised it didn't. It should have. What's going on? Okay, that's the most peculiar thing. It should give sex as an option here. Except, in this model, do we have sex as a characteristic? No, we don't. Okay, no wonder. So that was for the other model, but we would have been able to choose sex here. In this case, we're going to have a continuous distribution, and we can draw it from frequency table, ranges, or observed samples. Here we can specify for interval start, interval end, some sort of relative number of observations. So, from 0 to 10 years old, maybe we have comparatively more kids, from comparatively more people. From 10 to 20, maybe it's a bit less. From 20 to 30, maybe we have 15, and then from 30 to 40, also 15, 40. I don't think so. I don't think it can deal with overlapping values. No. Except these are continuous endpoints, so it can. You could say 30 to 40 and then 40 to 50 because it's essentially. No, I meant you putting like 9.9 and then you start using simple at 10 and then. Oh, no, you don't have to do that. It'll take, it essentially will allow for the end point of one and the start point of the other to be the same. But that's all. They can't overlap, 0 to 5 and then 4 to 6 or something like that. And then maybe 50 to 60 will make it, fewer, and then 60 to 70 will make it 10, and then 70 to 80 will make it 5, and then 80 to 90 will make it 2, something like that. This is a custom distribution, and this will allow us to draw values from it. We can go preview it here, and you'll see here it's actually drawn values from this distribution. We can see that there's a declining number of people by age. You could obviously specify an arbitrary numbers in here. So here we have this custom distribution for the initial age distribution. Okay, are people comfortable with that? The exact numbers I put in are not anything worth worrying about. Yes. Yes. Right. It's right. Okay. So this number of observations is just a relative thing. How many on a relative basis? How many fall into here? It's kind of it's turning this into a custom distribution in the sense that all these get normalized in the end. So whether this was if we'd specified all of these as 100 times larger consistently, the results would have been the same. I don't know if that's helpful. Yeah. Okay. Now, one thing though, I will say that I thought you might be asking, and it's a question that's a very practical one. Is well, okay, so this is all fine and good. We have one here, these ranges we can give number of observations, but how do you deal with multivariate things where we don't have distribution by age and sex, for example, or age, sex, and ethnicity? How would you do that? Broadly speaking, the recourse here is any logic yet support this. Jeff and I have been working on them, but they don't yet support this, and I'm not sure they will awfully soon. We've been seeing a number of custom objects for health modeling specifically. Jeff and I have been working on it, and several of our others. That we may end up producing something for multivariate distributions and pull from them. Using any number of different SAM techniques, but fundamentally, if you do want to do that now, the best way to do it is probably conditional distribution. So you have an initial age distribution for men, initial age distribution for females, and basically you need to reduce it to univariate distributions in that sort of way. There's no way right now having a multivariate specification here, but by conditional decomposition of your multivariate distribution into essentially products of conditional and then marginal distributions, you a long way. So It's not perfect, but you can get around with this if you're willing to kind of recognize that you may need different initial age distributions for male, initial age distribution for female, or initial age distribution for Maori and Torres Strait Islanders, or what have you, ethnic specific distributions. That would be the sort of way to work around it right now. Dylan, yes.
I'll also point out that any logic allows you to read in stuff from a database or a spreadsheet or a file, and another quick and dirty solution to it is basically to say these are all my fields of interest: sex, ethnicity, age band, and cancer status, let's say. For each one of those combinations, you could have a particular rate that you care about. It's not exactly the most compact solution, but it's a relatively easy one to understand. So, and manipulate if you just have a spreadsheet sitting in front of you. But that's a little more advanced than we'll cover.
Yeah. The other thing though is so there's one issue of sort of creating a initial population with a certain number in each cell, as it were, demographic cell. But then there's another issue of sampling from that. It turns out, sort of sampling from it probabilistically, and that both can be done. But it's a little bit more mechanism in both cases. Okay, so this is initial age distribution. Yeah. 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 I mean, it's a very good tool for that sort of stuff. I'm not going to say that, and it would not be correct to say that all these things are built in, but yes, you could readily work within the scope of sort of standard demographic projections or demographic, updating demographic data over time, and you'd have to pick your solution. It may involve some data that's read in directly from a database. It may involve putting in place some custom code to reflect the growing birth rate or shrinking birth rates in certain age groups or what have you. But you should be able to readily incorporate those in a model like this. It's not that big a problem. Yeah. It's just what I'm saying is it's not built in. It's not built into the software, but it can be readily done. Yeah. Yeah, you should be able to put in there pretty easily. I mean, I think you could. The thing that you'd have to be really careful about, and this gets into sort of more subtle modeling issues. They may have a population progression, but the one thing you'd have to be careful about, and I'm not sure if I'm understanding your idea properly here. So they may have a population progression over many decades, right? And if your simulation extends over many decades as well, now suddenly you've got, their numbers for the population with your numbers for the population, sort of people with different characteristics, and bringing those together, their sort of progression with yours is going to be more challenging. What would be I think a better way to approach it would be, instead of just using their numbers, their breakdown for the population of 2030 or something like that, what you instead get from the population progressions is rates of change of, birth rate, death rates, immigration or what have you, and you put those into your model so that your agents are subjected to those forces. And then you don't have this issue of, how do you kind of mesh their cell counts with your cell counts from your model. Yeah. Right. Exactly. Yeah. That can work very well. Yeah. So that would be my suggestion. We'd want to talk a little bit more about the specifics of your situation for me to be sure that I've understood it, but that's my kind of reading of what you're saying. And having worked with population projection data before, I think we're on the same page. So, okay, great question. Okay, so ladies and gentlemen, we have this initial age distribution. That's great. How do we impose that on our model? Go to population. Good. And then what do we do? Well, for the birth time, we're going to, if we have a person who's age 20, and we want them to be age, we want them to be age 20 at the initial time of the model. What was their birth time? The model's starting at time 0, so their birth time would be minus 20, exactly. So what we actually want here is we want to have time be drawn from the initial, come on, this thing is initial age distribution. There we go. Okay, and I think we have to, Dylan, remind me with this guy. Yes, sorry. I think actually we need to provide it of course. What am I thinking? Sorry, my sleep-addled brain is not working well. So we just do this. So we just call off to this, and it draws from the initial age distribution. It draws from that distribution that we specified for the initial age. So if someone's to be 10 at time 0, they would be born at minus 10. If they're to be 55 at time 0, they were born at minus 55. Okay? Okay, great. So are we ready to forward? Can we run it? What do you think? Run or not? Run. Okay, so let's run it. Good. Okay, so now if we went and we looked at this population, we would find that this person, for example, is born at time minus 44. So how old were they at the start of the model? 44, and now they're 44.3 plus 3.86 years. This person was 9, etc. Okay, so they're of different ages initially. Very useful, very useful. Okay. Initial age distribution and imposing it on a population. Make sense? Okay. And I showed you custom distributions. Okay? This shall become a nugget.